Okay, YouTube, this is another video on solving a nonlinear inequality in which we're going to focus on a rational function and one in which we're going to have to simplify first. But this time, what I want to do is take just a purely algebraic approach and then check it graphically afterwards. So we have this rational expression here. We want to know for what values of x is it greater than this expression on the right. And so most importantly, we want to start by not setting it equal to 0, setting the right side equal to 0, possibly. It could be your left side, but getting 0 on a side. So we would say that I would subtract this expression here over to the left, and what I would end up with, that's a 5, is minus this rational expression from the right over x minus 3 being greater than or equal to 0. Or actually, no, not or equal to, sorry here, greater than 0. So what we need to do here is we need to find the zeros of this function as well as any vertical asymptotes, because one thing we know is that our function value can change at vertical asymptotes, or it could change at zeros from being positive to negative or vice versa. So to make that a little bit easier, what we're going to need to do here is get a common denominator. And so I'm going to take everything on the left here times x minus 3 over x minus 3 here, or times 1 really. And then on the right here, we would say that, you know, the common denominator, at least the least common denominator, would be the product of our two existing denominators here, so plus 5. So here we go. So multiplying this out, we would say now everybody is over this common denominator of x minus 3x plus 5. That's just going to happen. And on the we have a subtraction relationship here. Don't forget about this. Why don't we put that in first? But over here on the left, looks like we get 2x minus 6. And on the right side here, we get 1 times anything as itself, so x plus 5. And it's important that we go ahead and distribute this negative throughout. So let's go ahead and simplify this further. And this is still greater than 0. Let me get that in there. But we would have 2x minus x here would just be an x. And then negative 6 minus a positive 5, or negative 6 plus a negative 5 would be negative 11. And then this is all going to be over x minus 3x plus 5. So x minus 3, x plus 5. So here's my favorite part, I guess, about this expression. It's already factored on top and bottom. So what we need to do is find our critical values. And the critical values really are the zeros of the top and the bottom when you're talking about a rational expression. So the 0 of the top, looks like we have one at 11. And I also have a critical value at positive 3. And I would also have a critical value at negative 5. So what this is going to do is it's going to allow us to set up our number line here. And so the furthest left I go is negative 5. Let's do this. We'll go, this is negative 5 right here, and then we'll build up for 0. We'll go another 5. Another 5, and then how about one more 5? 1, 2, 3, 4, 5, 15. Okay, so we're going to mark our critical values here, which we had one at positive 11. We have one at positive 11. We have one at positive 3. We want to label those. And we also have one at negative 5. Boom, right there. So our test intervals, let's write this out. Test intervals are all going to break at these points. And so we would have an interval from negative infinity up to our first critical value, from that critical value to the next critical value, from that critical value to our last critical value, and from that critical value out to infinity. And so we want to just test some x values here. So I'm going to list just a nice battery of these. I would say negative 6 is one I'll test here. Here I'll test 0 for sure. Here I'll test 4 just because it's to the right of the 3. And then I'll test 12 here just because it's just beyond the 11. And so testing these, we're going to test them into the factored form. And I would say I would test it into this form right here. So I'm going to make this hopefully a little bit easier here. I'm just going to leave blanks in for our input fields there. And I'm going to put in our constants and say, okay, well, we're plugging in an x here, an x here, and an x here. And then try to go through and substitute these in. But we're asking, is it positive or is it negative? So also I'm going to fill this in. We have a value on top over 2 values on the bottom being greater than 0. And we're going to fill these in. So our first value here, negative 6. Negative 6, negative 6, negative 6. I can see that I would get a negative on top. I would get a negative here and a negative here. So what we really have is a negative over a negative times a negative relation here, or a negative over a positive, which is a negative, and that would not be greater than 0 there. So we would say we would reject the first interval here. So now looking at this next interval, we say negative 5 and 3. Well, 0 is very easy to test. And I'll plug in the zeros here, but I want you to see that we basically get negative 11 over negative 3 times positive 5. So a negative over a negative times a positive. So we'll put this in, a negative or a negative times a positive, or a negative over a negative, which is positive. So we can conclude that we're going to keep this interval right here. So purely algebraically, we would keep this. We would say now 4, let's plug in 4. 4, 4, 4. We get a negative over a positive times a positive. So we get a negative over a positive times a positive, or a negative over a positive, or a negative, and a negative is not greater than 0. So we're going to reject this as being in the solution set. And then the last one here, I'm happy to keep the 12 now that I don't have to undo those. We'd say I get a positive on top, I get a positive here, I get a positive here, and so it looks like we get a positive over a positive, which is a positive. So we're going to keep this interval. So the last thing I want to do here as we write our solutions is make a judgment call. We say, do we want to use brackets on any of these endpoints? And so looking back over here, I would say, well, the only one of our zeros that, critical values that was a 0, this is a 0, was this one. So it's about the only one we would actually maybe include, and that would have been if we had an or equal to in our inequality here, but we did not. And so I can tell you that we're not going to keep the 11 here that is a 0. But I would say we would reject the other two just because we would not include these -5 or 3 values as endpoints because they're asymptotic. So we'll say in our solution set we have -5 to 3 in union with 11 to infinity. And the last thing I want to do here is actually now go look at the graph of this. So this was my second equation in here, and I'm going to go ahead and hit graph. And so we see that we have this right here. You know, looking at this expression that we had combined here, or at least factored, I know that I would have had a first degree over a second degree when I multiply this out, and then the a value down here is 1, or the leading coefficient is 1 and 1. So I would say that looks like we have vertical asymptotes at +3 and -5. We can verify this here. We have +3 and -5. We have vertical asymptotes here. And then a horizontal asymptote must have been of 1 because our leading coefficients were 1 and 1. Actually, no. We have a bottom heavy degree thing, sorry. We have the x-axis as our asymptote here. We can see that the x-axis is indeed our asymptote. But we were asking, initially, we would say, where are this one's y values? Here. The y values, or the f of x values, greater than 0. We can see that they're greater than 0 on our graph, right in the middle interval here. And if I were to take my window out to, let's say, x max, go to 15, we'll be able to see that our graph actually goes from being negative y values to positive y values again. Actually, that's really hard to see. Let's change our window. How about this? From x is 0, we'll go out to 25, going by 5s here. 25 by 5s. Maybe it can pop above the x-axis again here. Well, very hard to see. So we'll change this to y min is 0. And our y max will go to 1. And that'll really zoom us in here on the right side of the graph. It'll be very distorted. But we can see that it pops above right here. And if this is, 5, 10, this is between 10 and 15 here. And it's right there at 11. That it changes from being negative y values to positive y values again. So that's how you solve a nonlinear inequality. Cheers.